So continuing with page 181, number 10, I have r equals tan squared 3 minus theta squared. So the first thing you got to understand with a trigonometric function with an exponent is that you should rewrite that with the exponent outside parentheses. So I have this function, and then that squared is really out here. So this, I haven't done any calculus. This is just rewriting the trigonometry. Then I'm going to do calculus. So this is r, and I'm going to do r prime. So when I go to do r prime, I'm going to notice that I have a function inside a function inside another function. So I have this power on the outside, and then I have this tangent function in the middle, and then at the very inside, I have the 3 minus theta squared. All right, so it's funcception. One function inside another. Should be a Parliament album, but as far as I know, it isn't. We're going to do r prime now, the derivative, also known as dr d theta. You could write that. And so to start with, we're going to do the very outside derivative, which means we're going to do the power rule. So the 2 is going to come out here, and we're going to drop that exponent 1. So bringing the 2 out, I'm going to have 2, but the inside is all going to stay the same. So that's what happens when we do power rule, or chain rule, is we do the derivative of the outside and keep the inside the same. So that outside derivative means I'm going to drop this 1. That's applying power rule and keeping the inside function the same. Okay, now I have to do times the derivative of the inside function. So that is what we usually call g prime. So what's the derivative of the inside function? Well, I have tangent, and I have 3 minus theta squared. So that 3 minus theta squared is another inside function. I'm going to keep it the same and do the derivative of the outside function, which is tangent. Derivative of tangent is secant squared, all right, but keeping that inside the same, 3 minus theta squared. All right, so I've again done the derivative of the outside, kept the inside the same. Now I just have to do one more derivative because I have still an inside function, so we're going to call that h prime just to distinguish it from g. And then I look at this and say, what is the derivative of 3 minus theta squared? It's negative 2 theta. Yeah, and I could really probably just leave that there, but it would be nice to at least combine the negative 2 and the 2 and have negative 4 tangent 3 minus theta squared, you know, drop the unnecessary power of 1, times secant squared of 3 minus theta squared. And I guess I would put the theta in the front, squink it in there, or a theta, negative 4 theta. Yeah, that'd be nice. All right, so there you go. I'm sorry I squinched that, but that's how it goes. All right, that's number 10. Let's move right along to number 12. So number 12, once again, I take issue with their notation. They write y equal, well, I mean, it's not that bad. So if you know, a college professor wrote that, yeah, he would expect you to know what that meant. But, you know, what it means is the ln of the square root of x. All right. So far I still have not done any calculus. This is all y. It is not y prime yet. I'm going to have to do a derivative of square root, so why don't I also rewrite that as ln of x to the 1/2 power. Okay, so now the way I have it written here, it looks like a chain rule. So we have an inside function, so I'm going to do the derivative of the outside function. So since I'm ready to do derivatives, I'm going to call it y prime now. You know, be really conscious of when you have y and when you have y prime. And don't write equals and then do the derivative, because this function is not equal to its derivative. New line, y prime equals. All right, so people get confused how to do the ln derivative when we have, you know, an inside function. Derivative of ln x is 1 over x, so the derivative of ln of x to the 1/2 is 1 over x to the 1/2. All right, and then I have to go times the derivative of the inside function. So times the derivative of the inside function is times 1/2 x to the negative 1/2. That's just using power rule. All right, so we can probably simplify that quite a bit and end up with 1 over square root x times 1 over 2 square root x. And that's the same as just 1 over 2x, isn't it? Makes me wonder if there's an easier way to do this. And there is. So what if I start this problem again and I say, look at that y equals ln of x to the 1/2 power. Don't I have a rule for logs that says I can just bring the exponent out of a log? So this is really y equals 1/2 of ln x. Look for ways like that you can simplify the problem. Then you can just say the 1/2 is, I almost did what I told you not to do, y prime equals, the 1/2 is a constant, so it stays on, and derivative of ln x is 1 over x. You got 1 over 2x. hey, look, same cookie, two different recipes. All right, next we will look at number 14.